All right, so today we're talking about our new Wi-Fi 7 access point. My name is Sean. I am the wireless product manager here at Zyxel North America. I'm going to start here first by talking a little bit about Wi-Fi 7 in general, the technology. We'll got a few slides on that, and then we'll go over to the new access point and talk directly about the hardware. So Wi-Fi 7 is the latest Wi-Fi standard to come out following Wi-Fi 6E. And it's got a number of promises here. So it's promising speeds of up to 46 gigabits per second. Obviously, there's no hardware out there today that supports that, but in theory, that's the maximum speed Wi-Fi 7 is going to be able to produce. Part of the reason they're able to do that is they've increased the QAM, or the encoding of data on there, from 1024-bit QAM to 4096-bit QAM with Wi-Fi 7. So that gives you about a 20% more data that can be sent during the same amount of time. Another way they're getting to these faster speeds is they've doubled the channel width. So it used to be the maximum channel width with 11AC was 80 megahertz. With 11AC Wave 2 and Wi-Fi 6, that got doubled to 160 megahertz channels. And now Wi-Fi 7 can support up to 320 megahertz channels. A new technology called Multilink Operation, which we'll talk about here in a second, and then multi-AP coordination. So it's the ability for APs to be able to talk to each other, to be able to coordinate airtime utilization, airtime sharing, when they may otherwise be causing interference. So one of the things that makes Wi-Fi 7 possible is the addition of this 6 gigahertz space. So traditionally, right, we started off in the early days of Wi-Fi, we were pretty much just using 2.4, ignoring 11A there. With the 11N and then forward, we've been using 5 gigahertz. So you can see here 5 gigahertz opens up a lot more RF spectrum than 2.4 has, with the promise of being able to have more access points in the same area without causing interference. Now, one of the trade-offs with that, though, is we've got more bandwidth. So in order to get these faster speeds, we started using wider channels. So with 2.4, we were using 20 megahertz channels. With 5 gigahertz, we went to 40 megahertz channels, then 80 megahertz channels, and then 160 megahertz channels. So as you can see, as we drop down here from 20, which gives us, I think, 26 non-overlapping channels, to 160 megahertz, now we've only got 2 non-overlapping channels if you're trying to take advantage of the maximum speed. So 6 gigahertz opens up an even bigger chunk of space. So 6 gigahertz gives us more available spectrum than 2.4 and 5 gigahertz combined. So now instead of just having 260 megahertz channels, you can have up to 7 non-overlapping 160 megahertz channels. So you can have 7 access points operating at 160 megahertz without any interference or overlap between the RF spectrum being used, provided they're using 6 gigahertz. And then again, with Wi-Fi 7 now, we've got 320 megahertz channels. So if you're using maximum speed, you've now got 3 non-overlapping channels before you start getting into interference issues. So when you get to 4, now you've got overlap again. Now, a key thing to keep in mind here is as frequency goes up, range goes down. So your 6 gigahertz radio is not going to cover the same amount of distance as your 5 gigahertz radio that you're used to. So if you are upgrading an existing network from Wi-Fi 5 or Wi-Fi 6 to Wi-Fi 7, and you want to have the same coverage with the 6 gigahertz part of the radio, you will need to add additional access points to cover the same area. So, and this Carl, I think will answer your question here. So multi-link operation is one of the new features here in Wi-Fi 7. So this is something I do want to talk about here for you. So this is probably the biggest change technology-wise between Wi-Fi 7 and other Wi-Fi technologies that's out there today. So currently with Wi-Fi 6 and everything before it, we have what we call single link operation. Basically, your access point probably has 2 radios, or in the case of Wi-Fi 6E, 3 radios. However, your client device is only able to talk to one of those radios at a time, right? It will connect to the 2.4 radio or the 5 gigahertz radio. So what Wi-Fi 7 changes for us here is the ability to basically communicate on multiple radios at the same time. So in theory, your client device could connect to the 2.4, the 5, and the 6 gigahertz radio um, on the same access point. Basically, what this does for us here is it can be used for a couple different purposes. One of those could be to simply aggregate the bandwidth across all three of those, so you get a higher, faster overall throughput. Another thing you can do here is use it for low latency or for better reliability. And the way you do that is you send the same data over multiple links. So you would send the same packets over, say, the 5 gigahertz radio and the 6 gigahertz radio at the same time. And if for some reason some of those packets got dropped, say for instance due to interference caused by another nearby access point or some other piece of industrial equipment putting RF noise, you don't have to retransmit the packet because hopefully that same packet came through on the other radio and you can just assemble it together there. So it's very similar to like SD-WAN, how SD-WAN makes things more reliable and faster and is good for VoIP. Same thing happens here with Multilink Operation. So you can send the same data and be guaranteed that nothing's going to get dropped or very little is going to get dropped because anything gets dropped on one radio, hopefully it comes through on the second radio. So that gives you lower latency. So you don't have to be waiting for packets to be rebroadcast, and it gives you better reliability. So those are the three different modes that they can have. So Carl was asking, when is multi-link operation going to be supported in the WBE660S? So that's a good thing to bring up here. In order for multi-link operation to work, not only does the access point have to support it, the client has to support it. And right now, there are very few clients out there that are Wi-Fi 7 compliant. So at the moment, we have not turned on multi-link operation on our access point because there's not enough clients out there to really test it and verify it for compatibility reasons. So we've decided to turn it off rather than risk having issues with compatibility with new clients as they first hit the market. We will turn it on at some point in the future. I cannot tell you exactly when. We have not announced a date. But once more clients are available that support it and we're able to test and verify compatibility, we will turn it on at some point in the future. It is just going to be a firmware update to enable that feature. Another kind of cool technology that's coming here with Wi-Fi 7 is what we call multi-RU-puncturing. So basically, as I mentioned, we can now use up these really wide channels, 320 megahertz channels with Wi-Fi 7. Now, part of the challenge we have with this is that older technology doesn't use these wider channels, and you may have a situation where you're using this really wide channel, but you've got neighboring devices that are legacy devices that are Wi-Fi 5 or Wi-Fi 6 that are using smaller channels. So with multi-RU puncturing, Wi-Fi 7 gives us the ability here to basically use a 320 megahertz channel, but open up part of it so it doesn't overlap and get interference from a different channel coming from a different access point that overlaps. So for instance, you've put in your access point and your neighbor has an older access point that's using a 40 megahertz channel that overlaps with your 320 megahertz channel. We're basically able to skip that 40 megahertz and use basically that 320 megahertz channel and just basically turn it into a 280 megahertz channel that skips where that interference might come from. So again, it's going to be something that's going to be really handy for those looking to get maximum speed, but are in an environment where you have neighboring devices that you don't have access to be able to control the channel utilization. So it'll be good in office buildings where there's multi-tenant office buildings. It'll be good in apartments, condos, things like that. So just to try to summarize here, just some of the changes we've seen over the last few years. Wi-Fi 5, aka 11AC, first came out back in 2013, and it only improved the 5 gigahertz radio. So if you're using an 11AC product, your 2.4 radio is still using 11N or Wi-Fi 4. Then Wi-Fi 6 came out and originally launched in 2019, and that opened up a lot of changes to the 2.4 radio. So basically all the improvements that were available with Wi-Fi 6 on the 5 gigahertz radio are also available on the 2.4 radio. So that 2.4 radio is actually getting a 2-generation upgrade when it came to performance. Then Wi-Fi 6E came out in 2021, and that basically was just Wi-Fi 6, but extending it to cover 6 gigahertz spectrum as various countries started opening that up and allowing people to use it. And now we've got Wi-Fi 7. So Wi-Fi 7, you will note the launch date there is 2024, so in the future. And you're saying, well, Sean, you're selling Wi-Fi 7 products today. Why are you saying it's launching in the future? So there are Wi-Fi 7 products obviously available today, and we'll cover that here on this next slide, I think. Yeah, let's do that. So what you see here with Wi-Fi 7 is everything that's out there today is based on a draft spec. The Wi-Fi 7 spec itself has not been finalized or approved. So that's going to be something that happens next year, hopefully. So everything available today is based on the draft spec. So that's part of the reason why we've got these concerns with multi-link operation and interoperability between different vendors. Not only are there not a lot of products available right now, everything's based on the draft, so it's kind of a sort of Wild West situation. There is no third party doing certification at this point. The Wi-Fi Alliance, they will start doing Wi-Fi 7 certifications by the end of Q1 next year is what they're saying. So hopefully within the next 3 to 4 months, you will see them step in with upgraded guidance for it, specifically for interoperability and some testing, including interoperability testing. I don't know yet exactly which features they're going to require for certification for Wi-Fi 7. As we saw with Wi-Fi 6 and Wi-Fi 6E, these slowly added features to what was required for certification. So when Wi-Fi 6 first started getting certified, a number of features were not required that are part of the Wi-Fi 6 spec, and they've slowly added some of those in over time as the technology got a little bit more settled down. So we're sort of seeing that here. So right now, everything is based off the draft. Starting sometime next year, there should be the official ratification of the Wi-Fi 7 standard. Now, Wi-Fi 7 is going to be broken up into 2 releases. There's going to be release 1, which is next year, and release 2, which is probably going to be in 2025. So some features are release 2, some features are release 1. So if you remember earlier, I was talking about one of the features of Wi-Fi 7 was the ability for multiple APs to coordinate with each other. So that feature right now is expected to be a release 2 feature. So you probably aren't going to see any hardware that supports that for another couple of years. And in general, it remains to be seen what's going to be in release 1. So we can't promise 100% that, the final version release 1, what's available today can be upgraded to release 1 with firmware updates. We don't know that at this point. So that's something to keep in mind as well. As we were talking about here with client devices, there are some Wi-Fi 7 client devices out there today. There's not a lot. Wi-Fi 6E has been around for 2 years. Apple just got around with the iPhone 15 adding Wi-Fi 6E support this year. They did not include Wi-Fi 7 support. So iPhones will not get Wi-Fi 7 support until next year at the earliest, and it's possible they might not even get it at that point. The only phone I'm aware of in the US market that supports it right now, there may be others, but the only one I'm aware of is the Google Pixel 8 series. So the Pixel 8 series does support Wi-Fi 7. It is not clear for me from looking at reviews in the spec sheets whether they currently support multi-link operation or not. It looks like it should have it, but I haven't seen it mentioned in any of the reviews, and it isn't called out on their spec sheet. So it may be like something that they're waiting to enable at some point in the future. It may be there today. We'll see. I believe there are some larger client devices that have either just come out or are going to come out and ship before the end of the year that are basically like a PCI card that has Wi-Fi 7 support for desktop PCs. And I'm sure we'll see more devices coming out with Wi-Fi 7 support here in the near future. In general, though, Wi-Fi 7 support's really probably, not going to really start being widespread until later next year. And just like Wi-Fi 6E at this point is just, now starting to see adoption 2 years later. It'll probably be two plus years before it becomes much more widely supported. For instance, Wi-Fi 6E was just added to the Amazon Fire Sticks this year, but only their top of the line Fire Stick, the 4K Ultra Max or whatever it's called, version 2. Everything else is still using 2.4 and 5 gigahertz. So, it remains to be seen just how quickly Wi-Fi 7 clients are going to become something that's widespread and available. So the reason you'd be buying Wi-Fi 7 today isn't for what it can offer today. It's for sort of future proofing your networks and being there for what's going to be there in the future. Now, Wi-Fi 7 obviously is backwards compatible with Wi-Fi 6E. So there are a pretty decent number of Wi-Fi 6E client devices that are out there today. All your people using the latest iPhone have 6E support. So they would be able to connect to the 6 gigahertz radio. They just won't be able to, take advantage of the new features that Wi-Fi 7 offers. So now let's talk a little bit about our hardware. So our first Wi-Fi 7 access point is the Zyxel WBE660S. So this is a a tri-radio access point. So we are offering Wi-Fi 7 across all three radios, 2.4, 5, and 6 gigahertz. So this is sort of like our flagship access point. So it's a Nebula Flex Pro access point. So it includes 1 year Pro Pack license when you buy it for our Nebula cloud management platform. For those of you who aren't familiar with it, Nebula is our free cloud managed platform for managing our access points, switches, security routers, LTE routers, and stuff like that. Nebula Flex or the Pro license unlocks some additional features for you above and beyond what's in the free version of Nebula. It supports, in theory, speeds up to 22 gigabits per second. Now that's going to be your data rate. So real world, it's going to be less than that, what you see, but it's a lot faster than anything else we've put out up to this point. It has our smart antenna technology in it. And if we look at the construction here, it uses the typical Zyxel construction philosophy, which is aimed at creating better isolation for our antennas by keeping them off the main board and putting a separator behind them, and our focus on heat dissipation, drawing heat off that main board for improved longevity, solving that heat fatigue issue that plagues, enclosed devices like this. This access point, in addition to the 3 radios for Wi-Fi, also has a Bluetooth radio built in for BLE. This is a technology that's there to be used primarily for some sort of smart applications. Basically, it allows the access point to put out a beacon identifying itself. So when devices are nearby, they can see that beacon and you can integrate that with applications, etc. We have seen this used in museums for self-guided tours where they give the people a little phone device or a tablet with some headphones. And as you walk around, it is able to determine where you are in the museum. And so you can select, which spiels to hear as part of the audio tour. We have our 4G and 5G cellular co-interference filtering built in onto the board here for better isolation. It is a 10 gig Ethernet uplink port for you to help provide enough bandwidth for all those wireless users. Again, the wireless speed is, data rates up to 22 gigabits per second. So realistically, you're looking somewhere probably around 10 to 14 overall in your wireless, which you would see with like a speed test. So we give you a 10 gig uplink there. So that's going to be your bottleneck, but not that much of a bottleneck. When it comes to providing power, I think we've got this on the next slide here. It can be powered with Bluetooth, but you do need to have a PoE++ or 802.3 BT PoE compatible device to fully power up this access point at full speed. So something to keep in mind, your existing, if you've got some older switches, probably are not providing enough power to fully power up the access point here for you. We do have the ability also to power the access point with USB-C. So all you need is a USB-C charger that provides PD power delivery of 45 watts or more, and you can power the access point. That is how I am powering the one that I'm testing in my house. I am using a USB adapter to provide that power at full speed there for it. And it does have a 1 gig pass-through port, so you can daisy chain to an additional device in the area there. You will also notice, rather than having a heat sink built in that goes between the case and the board, we have made the bottom of the case a heat sink, We've got some big fins here to help dissipate heat behind the access point and draw that heat off of the board. This also acts as an anti-noise shield to help prevent interference. Mounting bracket is very similar to what you were already seeing on our NWA and WAX access points, just modified a little bit to be able to fit the shape of the housing here. But it allows you basically to clip this onto T-rail. It allows you to mount it to various different types of junction boxes. We've got different screw layouts here for just about every type of junction box that's out there. So as I mentioned earlier, the access point does work with Nebula. So again, Nebula is our free cloud managed platform. I'm not going to talk any more about Nebula today. If you're not already familiar with it, we do a monthly webinar on Nebula. You can join that. We talk a little bit more about what Nebula offers for you. But it's a free cloud platform for your management uses. And I do want to take a couple slides here to talk about smart antenna, because smart antenna, the technology we use, is not that common in the business space. Cisco doesn't offer it, Aruba doesn't offer it. It's pretty much just us and Ruckus with their BeamFlex Plus that offer this type of technology. So smart antenna technology is something that's been designed to increase the capacity of the access points to allow you to get more users onto the same access point before you run into airtime issues. It's designed to improve coverage and help cover a larger area, and it's been designed to help solve interference issues. So your typical access point is designed with one fixed antenna pattern, and it just assumes you're mounting the access point over the area to be covered, and it radiates the signal out in roughly a circular pattern aimed slightly downwards. Now, when you have other sources of interference, in this case, it's a microwave on the slide, but other access points, other Wi-Fi devices that are using overlapping channels or bordering channels can cause what we call co-channel interference. So with smart antenna technology, instead of having that one fixed antenna pattern, we have an array of antennas that can create hundreds of different antenna patterns, optimizing the signal for what's needed in that environment. So it can choose a signal not only that optimizes the antenna pattern based on where the client device is in relationship to the access point, it can specifically choose an antenna pattern that allows it to help ignore interference coming from neighboring access points or other sources of RF interference. If you go through our Wi-Fi 101 presentation, I do a more in-depth deep dive on this, but it actually allows you, when you have a multi-AP deployment where there is overlap, it allows you to achieve more than 100% airtime utilization. You can get up to 150% airtime utilization, where theoretically 100% is the max. And usually without smart antenna, when you've got a multi-AP deployment, your airtime utilization is normally somewhere around 75 to 90%. With smart antenna, you can bump that up to 150%. So it makes a huge difference in environments where there's a lot of interference. So now the question becomes, what are the applications for Wi-Fi 7? Where is Wi-Fi 7 going to take off? Where should I be looking at using Wi-Fi 7 today? So the first main area for Wi-Fi 7 is going to be high density locations, areas where you've either got a lot of users on the Wi-Fi network, or you've got a lot of access points in the area, or you've got both. And the reason for that is you've got faster speeds. So providing the clients are Wi-Fi 7, that means the client devices are using less airtime to send the same amount of data because of those faster data rates. So therefore, you can have more users on there before you start stepping on each other's toes. In addition, because Wi-Fi 7 is able to use that 6 gigahertz spectrum, which is just gigantic, you can have a lot of access points in the same general area, and they won't be on overlapping 6 gigahertz channels, so they won't be interfering with each other. So if you've got an area where you need a lot of access points in the same area, or you've got something like a big expo hall where you've just got a lot of wide open space, Wi-Fi 7 is going to be a benefit there for you as well. Other areas for it, we see this as sort of being the technology that might bring mesh, finally, after all these years, bring mesh out of the home and into the business environment. basically allowing you to place access points where you don't necessarily have access to an Ethernet drop for backhaul. You can now create a wireless mesh using that 6 gigahertz radio. And especially with how few client devices today support 6 gigahertz and how few support 7 in particular, this might be a really good application in the future here, using that 6 gigahertz radio to create your mesh and freeing up your 2.4 and 5 gigahertz radios to only talk to the client devices and not also have to rebroadcast on those frequencies for the mesh link. So you move mesh to 6 gigahertz and you dedicate 2.4 and 5 to your client devices, which is what most of your client devices are going to be using. And again, because the access points are USB-C powered, really easy and convenient to be able to put them pretty much anywhere you want them to have access to something. And then the other area for this is going to be high bandwidth applications, right? You're going to be able to provide, data rates of around 10 gigabits per second. So it allows you to send, for instance, video uncompressed. Now, normally when you're sending video, for instance, if you're using like an Oculus Quest 2 or 3 and you're streaming video from your PC to the Quest, your PC has to compress the video, send the video, and then the Quest has to uncompress the video and display it, and that adds latency. So with Wi-Fi 7, there's enough bandwidth there for a number of video applications and things like that where you don't need to compress the video. You can just send it raw, getting rid of that extra latency and delay, which is going to be really nice. And that, guys, ends today's presentation on our Wi-Fi 7 access point. Again, if you have questions, send them in using the question and answer box in the Zoom interface, and I'll be happy to answer them now for you while I'm waiting for some questions to come in. Just want to draw your attention to YouTube. There's a lot of different Zyxel channels there because we're a big multinational corporation. So the US office is Zyxel America channel. So if you go to YouTube and type that in, you will find our channel. Most of our webinars are recorded and posted there within 24 to 36 hours after the webinar. So if you've missed a webinar you wanted to see or you had to step out, you can go there to find it. We also use our YouTube channel to be able to provide we have video case studies on there. We have some best practices videos, new product announcements, things like that. And then you can also find us here on LinkedIn. Feel free to link us up there. I'll still kick around here for a few more seconds in case anyone has questions. I also will draw your attention to our user forums, forum.zyxel.com. It's user forums we put there to allow Zyxel resellers and users to be able to talk to each other, help each other out. It is monitored, though, by our headquarters from both R&D and product management. So they keep an eye on that to give priority to new feature suggestions and things like that. We will occasionally wade in and answer questions there. It's also often the first place where we are going to post up things like security announcements, release notes, and things like that. Okay, we don't have any questions, so I am going to go ahead and end today's webinar. Thank you for joining us today. I appreciate you turning out, and I hope I see you on one of our future webinars.